Good evening. Let's get started. I wanted to emphasize a few things before we do the class exercise or the lab. One thing is regarding while loops. I wanted to show you some things that we have already seen, but I want to repeat that because that is quite important.
Professor,
Yes.
for assignment 10, there's no Dropbox.
Okay. I will create it right now. I probably didn't unhide it. Give me a second. Okay. Assignment 10. All right. It should be there now. Thank you for reminding me. I wanted to say one thing about while loops. When you have a while loop, you write while, you put a condition here, and obviously you put a colon and you put a bunch of statements. Now, in many while loops, I won't say every while loop, but many of them, you will need to do some work before getting into the while loop. So there will be some statements here, and there will be corresponding statements at the end of the while loop. So whatever you do here, there will be corresponding stuff here as well at the end of each iteration. You can think of this as a 0th iteration. That is, you have done no iterations, but you still need to do some work before you start the iterations. So think of the end of the 0th iteration. You do some initialization, do some work, and then at the end of the iteration, you do something, maybe the same thing or something related. For example, if you're accumulating a bunch of numbers, this would be, if you're adding up a bunch of numbers, you will have total equals 0. And there would be related code here, but that would be total equals total plus something, whatever that you want to add. So see, this happens before you get into the while loop, and this is at the end of the iteration. That is one thing. The second thing is, here with respect to the condition, you'll have some condition, maybe total is less than 75. So you have initialized total, you're looking whether total is less than 75. If so, you are carrying out an iteration and then accumulating total. So total is properly initialized and it is getting updated. So this works out fine. But suppose your condition was something like, while number is greater than 0. Then you need to initialize the number before getting in. Otherwise, this will be a crash. So the number might be something you invent. It could be a random number, or it could be something from the keyboard. So you could be having something like int input, some display here, right? But then you should have corresponding code here too. Otherwise, that number will not change and you will never get out of the loop. Input that code here. So look at this here where number is given a value so that you can use it, and then number is read in again at the end of each iteration. We went over all this when we discussed while loops, but I thought it was necessary for me to point this out again as I was looking at your lab work from last week. So you have to understand this idea thoroughly. Problems are going to be different. You will probably never see a problem that we have solved in this course anywhere else in your courses at Metro State. But you should understand the principles, right? So it is important to see some examples, but it is even more important for you to solve problems after seeing those examples. Looking at 100 different examples won't really help you unless you attempt problems on your own, do them independently without anybody's help. Okay, you can seek help from others in solving your problems, but then it will not do you any good when you are trying to do that at work. Okay, so I just wanted to emphasize that idea. The other thing is regarding functions. Something again I saw last week. Some of you had stuff like this. Define, add, and then a equals int input, enter something, some stuff here, b equals similar stuff, and then you had c equals a plus b, and then you said print a comma plus b comma equals c. And you had calculate. I'm running short of space here, but anyway, I'll try. Calculate. And then you had somewhere below a call to add. And some of you wrote calculate, you called calculate from here. That is, calculate calls add calls calculate back. This is legal and it is sometimes done, but doing that in this context is highly inefficient and you should not do that. This is called a recursion. Let me see the thing. From calculate, you're calling add, and add calls calculate back. And this again calls add calls calculate. So it is, they are calling each other. And you keep doing that until the program ends. What is wrong with this kind of an approach? Well, you initially call calculate, and that takes up some memory from the system. calculate calls add, which takes up some memory from the system. The first calculate is still suspended. Then add is called. Then you call calculate again, which calls add. So you're consuming more and more memory, and at some point in time, you will use up all the memory that the system has given to your program, and the program will crash. This is called recursion. Recursion is useful, but you should not use it willy-nilly. You will see its use in ICS 141, and if you take ICS 240, you will see it again. It is a very useful problem-solving technique, but it is not appropriate for a context like this. You should not do it. Instead, you should simply have something like while command is not equal to exit, call add or subtract, depending upon what the command was. If command equals A, call add, else if command equals subtract, equals subtract, call subtract, and so on. This should have been calculated. And I had suggested this as the recommended approach, but some of you did not obviously look at that or did not follow that. And that is not calling these back and forth is not an acceptable way of solving this problem. Add should simply add and come back. Then you get the next command and then ask whether it is exit. If it is exit, you quit. Otherwise, you call one of these functions again. Any questions on this? All right. But then the other thing that I wanted to say was regarding this week's material. Let me share the PowerPoint slide. Yeah. Okay. Okay. I don't like putting a lot of colors in my slides, but this I felt was the only way to get your attention. Okay. Because I have been repeating this over several semesters, and some students don't seem to fully appreciate the importance of all this. So please pay attention to this. 15 minutes of properly understanding, 15 minutes spent properly understanding these suggestions would save you hours of frustration, okay? And writing buggy code that doesn't work and then wondering what is going on. Spend a little bit of time looking at all these reasons, all these suggestions, and remembering them. You have to remember quite a bit in this course. There is no escape from those things. The first thing is, do not modify a parameter before using it in your functions. What do we mean? Okay, let's take some examples. For example, here is a function. It has add, or maybe I have another one. Yeah, let's look at this. Define my nonsensical function That is the name I gave to this function. It has a parameter a, which means you have a value in a when the function starts. At the beginning of this function, when it gets executed, a has a value. The user would have given it a value. And this function simply forgets about that and asks for a value from the user, from the keyboard. Then why are you getting this? Why is this function asking for a value in a parameter? Why is it making the caller pass a value? You can't call my nonsensical function without supplying a value. And this simply says, I'm not going to use it. Then why? Why did you bother? Right? Why did the function bother about getting a value here? So this is absolutely wrong. You should use this value here. That is why it was given to you, right? The function is not doing it. So that is incorrect. So please remember that. The second thing is here. Here is a function add. It gets two parameters a and b. There are values there, and the function adds a and b and returns the result. If a function returns a result, you should use it. For example, I'm calling add here with x and y. X and y are values that I accepted from the keyboard. So I'm interested in getting the sum of x and y. If x is 2, y is 3, I would like to see what 2 plus 3 is. If you call add with x and y, and the function returns the sum, where is it stored? The result just vanishes into thin air with code like this. Then what was the point of calling add? If you write code like this, int input, enter a number, and not store the value anywhere, what was the point? You just made the user type in some stuff, and it was never stored anywhere, never used anywhere. So instead, you would write stuff like this: x equals int input, enter a number, right? Similarly here, add gives you a value back. If you don't use it, it is possible that you are making a mistake. So I won't say this is absolutely wrong, because add might do other things. In this case, it doesn't, but a function could do other things, and then that would be probably useful. For example, here, the input function at least makes the program wait and display this message. Maybe that was your only intention. If that is the case, one can be forgiven for not using this value back, the value that is returned. But if your intention was to get a value from the user, you have to have x equals, or at least you have to print this value or use it in a computation, whatever. That is the second thing. These are common mistakes. So please do not forget to check for these things as you are coding your programs. Do not use the same identifier for functions and variables. This can be very confusing. If you have a function called calculate, don't invent a variable called calculate. You can get into trouble if you did that. There are an infinite number of variables possible, identifiers possible. So please don't reuse the identifiers for functions and variables. Then something like this. When you are calling a function, use parentheses. If you code like this, which is a common mistake, define function f, which returns some value. It doesn't really matter what it is. And I can code like this: print f comma 3, but you will see strange results coming your way. If it will print something, but it will not be 4. And you will wonder what is going on. The problem is that we didn't put parentheses after F. So as you are coding tonight's lab, when you are doing the lab, make sure that you did not violate any of these rules. I have repeated these in the lab handout too, but I would urge you to check your code and see if you have committed any of these mistakes. Do the same thing whenever you code your functions, pay some attention to that. And after a while, after you code a few programs using functions, you would be unlikely to repeat these mistakes. You would unlikely to be making these errors that can be very frustrating. So start checking for these things tonight in your programs. In the class exercise, I have given some problems that are addressing these issues again, because this is terribly important. Okay, so I wanted to talk about it first thing this evening. I can't overemphasize the importance of these requirements, because it can be very frustrating for you if you start doing these kinds of things. Your program won't work, and then you will be wondering what is going on here, and you will be spending hours trying to understand the mistakes you made. Instead, check for these things in your code itself before running them. Okay. Any questions before we get to the class exercise? Anybody?
What class exercise are we on? Because before it said classwork 13 updated and then it was erased. I don't know if anyone else saw that.
What classwork?
Classwork 13.
Class exercise, I will make it available in a few minutes. Yeah. So it doesn't matter what the messages were.
No, it said it was already graded and then it deleted.
Yeah, that is probably a mistake. Yeah, I will spend a minute or two checking that out before making it available. Or maybe I have already made it available. I don't remember. I'll take care of that. But thank you for making that observation. Any other questions?
Yeah, please, can you make an example how to change parameters? Because I'm not very clear about that.
I mean, where parameters can be, how parameters can be changed?
Yeah.
There are examples like this, but for example, here, I have changed parameters, right? It changes the parameter A, but it doesn't change the original, okay? For example, I'll maybe code a Python program rather than show you the slides, because I'm sure you have watched this slide, so that may not be all that.
Yeah, yes, please.
Okay, give me 1 minute.
Okay.
Let me open up Python and right. Oops. Okay. I'll show you my code in a minute, okay? Because I'm thinking of, I mean, I'm cooking a problem. So I'm cooking
Okay.
up a problem. So give me 1 minute. I will.
Yeah, okay.
Yeah. Okay. I think I am ready to share my code with you. Okay. So can you see my Python?
Yes.
Idle. Okay. So what I am going to do is I will do something that is kind of similar to what you did for one of the assignments. I'm going to read in the initial principal of a deposit, initial value equals, let me use all integers. It doesn't really matter what the problem is. So
Yeah, okay.
enter initial amount. And let me also read the interest rate equals int input interest rate. And maybe number of years. Equals int input enter number of years. Now, what I would like to do is, or maybe let me run this and see what happens. Nothing much actually.
Yes.
Actually, because I haven't even called process, I didn't realize
Yeah.
that. Okay. So let me call process and let's see how far. Oh, I don't have. Okay. There is some keyword here you can put. I think it is pass or something. I don't know. Yeah. What happened? Oh, I'm missing the left parenthesis. Okay. All right. It asks for an initial amount. Let me say 200, 10% interest, and I would like to find what the
Yeah,
value would
we
be.
are seeing only the idle, not the
Oh,
Python.
yeah, that is true. Okay, yeah, that is true. Let me share
Okay.
the desktop. All right.
Okay. Yes, we are seeing.
So this is just accepting the initial amount, the interest rate, and number of years. I entered some values here, basically asking to get the principal after 7 years with 10% interest rate for an initial deposit of 200. But of course, I am not really doing anything yet. So all the work would be done by this. So I'm accepting, or maybe I'll just write period here just to make it shorter. Okay, so I'm accepting all these three values, the initial value as principal, interest rate as interest rate, number of years would be period. So I will call this function here with principal, interest value. I'm missing an L there. I'm not too worried. I'm going to worry about it. Interest rate is the second parameter, and number of years would be the third parameter. Okay, so that is my call. Even now it doesn't do anything because as you can see, I can put in numbers, but
Yeah, we haven't done any
we are
calculations.
not doing anything here. It simply says pass, which means go back. So I need to do some work here. So what I will do is I will put a for loop for year in range period. See, I know, to emphasize this point, I know that when this function is called, principal will have some value, interest rate will have some value, period will have some value. I just trust that. I don't read those things again because I have read in all those things. Somebody has read in all those things and he's giving me all those values. So I shouldn't be reading in anything. I just use these values here. And what I will do is I will change the principal. At the end of the first year, principal would be equal to principal times the interest rate divided by 100 plus principal. And I will print year plus 1. I will print the principal. Okay. So for every year, I will be recomputing the principal using the previous principal and print the year plus 1 because this is going to be 0, 1, 2, 3 onward. So I need to add 1 to that to show what it is after the first year, second year, etc. And the value of principal at the end of this year. So now let's run this. And notice that I am changing principal, which is a parameter. So this is a good example of a situation where I am modifying the parameter. So if I run this and put 200, 10% interest, and let's say for 5 years, what it does is it shows me that at the end of year 1, the value is 220, at the end of year 2, it is 242, etc., etc. So you have an example of a program that modifies the parameter. And if I print the principal here, what would be the value? With this input, what would be the value of principal when I print it here?
I think the first one.
It would be the original value. I think that is what you meant, right?
Yes.
It would be 200 because changing the parameter doesn't change the argument that I passed. Everything is copied. This essentially copied. I would say that. When I call print principal values, whatever is in initial value is copied into principal. Whatever is in interest rate is copied into this interest rate. Whatever is in number of years is copied into this period. So these are 3 different variables that last only during the execution of this function. So let's run this and you will see that principal in the function process doesn't change. Let me put in 200, 10, and 5. Oops, so what happened here? Oh, I don't have a variable called principal. I should really be using the interest value. I didn't realize that. Yeah. So let me run this again. Oops. Oops, give me a minute. Okay, at the bottom, 200, 10, 5. And you can see that the value of initial value hasn't changed. It is still 200. It doesn't matter what you call it here.
So I have another question. So why are you using two different names for the same argument?
The thing is, we all have our own favorite naming approaches, right? So there is no requirement that something should be called a principal or initial value as long as it is they convey the idea. So this shows that power of functions. I can call the variables here whatever I want. I have complete freedom, right? It doesn't affect anything else. It is not affected by anybody else. So if you and I write two different functions that go into the same program, we can name our variables as we please. I mean, of course, we have to follow naming conventions that are dictated by the organization, but we don't have to worry about whether the variable I use would be affected by what you are using. They are totally independent.
So this is when more than one person write the function, right?
Correct.
So if I'm writing the function from the beginning to end, I don't have to change the name of the parameters, right?
No. You can use whatever you think are acceptable names for those parameters and any local variables. For example, I have a local variable here, year, right?
Yes.
I chose that. There could be any year here. No problem. There is no conflict. So that is one of the advantages of using functions. We can develop functionalities independently without worrying about any kind of interference.
Okay, thank you very much.
Okay. Any other questions? Thank you for that question. It was an excellent question. Anything? Okay. If that is the case, let me go ahead and stop recording. Let me